Hello, great tens all over South Africa. This is Dups De Genius, your tutor at Genius Tuition Institute. And as we are in 2020, both the new grade 10s and the old grade 10s, I would like to welcome you, and I promise you mathematics is no longer going to be a monster to you. We are going to make a good situation out of this. So I welcome everyone. Now, as our topic states, converting recurring decimals into rational numbers. Now, let us recap from grade 9. If you still remember, we dealt with decimal fractions from the lower grades, grade 6, 7, etc. And we understood what decimal fraction is. It comes from a vulgar fraction, which is a common fraction. And now we are going to convert the recurring. What is a recurring? Now, a recurring decimal is a decimal fraction where a digit repeats itself and up to infinity. Sometimes there is only one digit repeating itself. Other times it can be 2, 3, 4, depending, that are repeating themselves. So, guys, we are now going to convert that into rational number. Let us just remind ourselves, what is a rational number? What is a rational number? Now, if numbers are rational numbers, they are numbers that can be written in the form A over B. A over B. Now, any number that can be written as a fraction is a rational number. So, how can we do that? Now, there are steps that we need to follow, guys. But let me first show you an example of rational numbers. Now, here we are, an example. That is those who are, I just want to show you the recurring. Now, all those numbers that are recurring, the first one, it can be 0, 1, and then sometimes you'll get a dot on top of a number, or in other books, some writers write them as this. They write them as 0, 1, and then on top there, it's a bar. We either use a bar or a dot on top of the number that repeats itself. That means this is 0,111111 up to infinity, guys. Now that is what they mean by recurring decimals. Now, how can we do that? Ooh, this seems to be a very interesting thing. And we are going to make it happen. Now, if you cook something delicious, that means you must have a proper recipe for that. So it's mathematics. When you want to convert, that is to change, that is converting. When you want to convert recurring decimal into rational numbers, into numbers that can be written as fractions, you need a recipe. Now I have it. And I'm going to give it to you guys. Watch the space. Now, here are the steps. The recipe. Yes, I call it recipe. Recipe. Now, recipe. Wow. This is excellent, guys. It's excellent. Recipe. Now, what is the recipe for? Let's write it down. Conversion from recurring decimals to rational number. Right. Now, step number 1. Recipe has a title and it also has steps. Now, let me start with the first step. What do I need? I need to form an equation. In order to do this, I must form an equation. Suppose it says that I do this. Yes, let me just, the phone is ringing, sorry. I just tapped it off. Now, yes, the first step, we define the equation. Say, for an example, we were given this. How can we define an equation with that? We because we don't know what is its value, we let x be equal to 0, 1. 0, 1 recurring. And then the secret here is how many digits are recurring. Recurring digits, that is only 1 digit. Recurring digits is only 1. So what I do, I take 10 times the number of recurring, and that gives me 10. Now, this gives me the second step. It gives me the second step where I am going to multiply step number 2. Step 2. Step 2. Step 2. Step 2, you multiply both sides of the equation by 10 times the number of times the number recurs. That is, how many numbers are recurring. Now, that is what you are going to do. Now, that will be the second step. Let's do it. We are going to take this step, x is equal to 0, that. How many times? It's only one digit recurring. Then we're going to multiply that by 10, and it gives us 10. Now, 10 times that will be 10x. And that is equal to 10 times that. Remember, we still have another one there. That will be 1, comma. If you multiply this by that, then it will be 1. Yes, 1, comma 1 recurring. Now, let's get to the next step. The next step is step number 3. Now, step number 3 is like this. Step number 3. Step number 3. What do you do? Step number 3, we subtract the first equation, because this will be the first equation. The first equation is that one that we were given. We formulated it. That is, x is equal to this. That will be equation number 1. Equation 1. Yes, equation number 1. Equation number 1. And this becomes equation number 2. Now, if you look at both, you have the first one is x is equal to 0, 1, and then the second one is 10x is equal to 1, 1. How did you do that? You multiplied the first by 10. 10 times x is 10x. 0, 1 recurring is equal to 1, 1. How did we get that? We moved this to the 1 space to the right. If you multiply by 10, the comma moves to the right. If you divide by 10, the comma moves to the left. Division, you go to the left. Multiplication, you go to the right. Now, if you multiply by 100, you are going to move that comma to either the right if you multiply or divide, either the right or left, by the number of zeros that you see there. If it's 100, 2 spaces. If it's 1,000, 3 spaces. That's it. So now, here, what we do, we now have to subtract. You subtract. What do you subtract? you subtract the bigger one from the smaller one from the bigger one. That is equation number 2. You subtract equation 2. You subtract equation 1, which is the smallest. You subtract equation 1 from equation 2. Now, how do we do that? This is what we do. When we write that, it will be, you take equation number 2. Equation number 2 is 10x. You take 10x, which is equal to 1, 1, recurring. And then you take that one. It's x, which is equal to 0, 1, recurring. Now, what do you do? This is equation number 1, and that is equation number 2. Equation 1, and then this one is equation number 2. No, it's equation number 2, equation number 1. Yes, this is stated that. So what do we do? You subtract. Now, when you subtract, you just make sure that you do the right things, guys. Never do a mistake there, because it will cost you dearly. It's going to cost you dearly, right? Let's subtract. 10x minus an x, that will give you 9x. And then this minus that, it's 0. 1 minus 0 is 1. Now, remember, we let x be equal to 0, 1. So here we are going to solve for x. Now, let us do that. We now have to divide both sides by 9. Divide by 9. And then what happens? Something beautiful happens. Here we are. 9 cancels 9. If you divide 9 by 9, you get 1. 1 times x. That gives you x. The final answer is x. Yes, that will be x. X is equal to, on that other side, wow, this is a fraction, numerator and a denominator. Oh my goodness. This is 1 over 9. But we were supposed to get 0, 1 recurring. Here I have x. Oh, let me go back. X is 0, 1. Now, therefore, I can come to my conclusion that, therefore, 0, 1 recurring is equal to 1 over 9. That's it. This is how you should do it, guys. This is how you should do it. Now, we have converted a decimal fraction, which is recurring, to a common fraction. So this is it. Now, let us check the other one. Sometimes you will find that you have a digit here which is not 0. How are we going to deal with that stuff? How are we going to deal with it? You know, what we need to do is, we have to make sure that everything that we do here is correct. So we are going to make it happen. We use the first in order to get the next. Yes. Now, suppose we have this. Suppose we have this. Let me do this. Yeah. Suppose we have yeah. Suppose we have yeah. Suppose we have it's 5. Yeah, 2,5. Yeah, it's 2,1 recurring. 2,1 recurring. How are we going to deal with that? 2,1 recurring. Now, if we have something like that, then what do we do? Let us recap. Let us recap our recipe. Let us recap our recipe. Here it is. Step number 1, let x be equal to that recurring number. Step number 2, multiply both sides by 10 times the number of recurring digits. Step number 3, subtract the first the equations. Fine. Now let's do it. Let's do it. We let this be equal to, this must be equal to x. That is step number 1. Now, step number 2, how many digits recurs? It's 1. Therefore, what do? We take it's 10 times the number of recurring, and that gives us 10. So, we continue. This is equation number 1, guys. Equation number 1. It's equation number 1. Then equation number 2, what do? We multiply by 10. And when we multiply by 10, what do we get? We get this times 10. That will give you 21. Remember, we move one digit to the right. It's 21,1 recurring, which is equal to 10 times x. That gives you 10x. And this becomes our second equation. This is our second equation. So the next thing that we do, step number 3, what do? We subtract this one from this. Then that is what we do. You will set equation number 2 minus equation number 1. Then that will be 10 minus 10x minus x. That gives us, 9x, and then equals 21,1 minus 2,1. 1,1, 0. 21 minus that gives us 19. Wow. And then what do? We divide both sides by 9. We must get rid of the digit in order to get the literal coefficients. We divide by 9, divide by 9. And then what is our next move? Our next move is to do like this. This divides with this, it gives you 1. 9 over 9 is 1 multiplied by x, and that will give us x. That gives us x. And then this is 19. The final answer is 19 over 9. And if you want to write it as a mixed number, it will be like x is equal to how many 18s are in there? It is 2. And then how many 9s are there in 19? We have 2 because that is 9 times 2. It gives you 18. Now, when you subtract there, you get a fraction, which is 1 over 9. Now, meaning this 2, 1 is equal to 2 and 1 over 9. And this is in the form of a mixed number. It's a mixed number, guys. Mixed number. This is a mixed number. And whereas this one, it's an improper fraction. It's a fractional form. Now, which is improper fraction. It is improper. Why is it improper? Because it is greater than 1. All fractions are, no, not all. We have fractions that are less than 1 and fractions that are greater than 1. So guys, in mathematics, when you talk, you have to be very, very, very careful. Never utter a wrong statement. Like for an example, there is a tendency of saying in exponents of saying any number to the power 0 is 1. No. That statement is not true. It was supposed to be true if you said most of the numbers to the power 0 is 1. That means there are some or 1 which is not going to be like that. Like, let's take 1 to the power 0. Yes, it's 1. But what about 0 to the power 0? 0 is a number. So, that is meaningless. So, the statement that was uttered first is wrong. Okay, let's continue. Now, we did this one. Only one digit was recurring. Now, let's get to another one where we have 2 recurring digits. 2 recurring digits. Now, here we have 2 recurring digits. How are we going to solve that? Remember, we have a recipe, yeah? Remember, we have a recipe. So how are we going to solve that? We are going to make it. The same recipe is going to be used. So here we have 0.53. 0.53. These two numbers, digits, recurs. Okay. Using our recipe, we know that we let this be equal to x. And then, how many digits recurs here? It's 2. So what do? We take the recurring, that will be 10 times the number of recurring. Nope, not 10 times that. It's 10 to the power that. That means it's 10 to the power that. That will be equal to, we can say then times 1. 10 to the power recurring numbers, then that will give us 100. That means you multiply that by 10. Yes, is 10 by 10. How many 10s are multiplying each other? In the first is 1. Here, the number of digits is 2. It tells us how many 10s are multiplying each other, guys. Let us be clear on that. How many 10s are multiplying themselves? 2, because we have 2 recurring digits. So that will be exponential. It's 10 to the power 2, which is 10 times 10, and that is 100. So we are going to multiply here by 100. If we multiply here by 100, multiplication will go to the right. How many zeros do we have? 2. It's 1, 2. So this will be 53,53 recurring. So the final answer here, when you multiply by 100, that will be 100x. So what do? We subtract the bigger one, subtract the lesser one. This minus that, we subtract. This minus that one, that gives you 99x. And then this minus that gives you 53. So what do? We divide both sides by 99. And therefore, our final answer, x. Our final answer is x is equal to 53 over 99. Now from this too, we saw that the first one, let us look, for interest's sake, let us look at the digits. I mean the denominator at the final answer. Here, look at the digit here. It's 9. It's 9, guys. Only 1, 9. Good. Now let's, why? Because there was only one recurring number. Now let's get to this one. How many recurring numbers? 2 digits that are recurring. Now let us look at the digits below. That is the denominator. How many 9s are there? 1, 2. Now we can come to the conclusion. That, you know what? What do we realize? We realize that when you have 1 digit, the denominator is going to be 1, 9. When you have 2 digits recurring, the denominator will be 2 9s. Now we can just, hey, it's like rap, eh? Yes, we can now come to the conclusion. That is a rule. Now the rule is, what you do is you multiply, it is 10 to the power the number of recurring digits, and then what do you do to that? You subtract 1. Subtraction, let it be read. Subtract 1. Let it be red. Now this will be the rule. 4 for the denominator. Your denominator is going to be look like that. Now, this is for the denominator. And that's it. And then, look, this is 53. It went on top. Now, meaning, you just take the recurring number, put it on the recurring. Another rule is the recurring. This is the denominator. Now, what about the numerator? What about the numerator? Hey, mathematics. So interesting. For the numerator, you write the recurring number. The recurring number. The recurring, let me just do this. The recurring number. You write the recurring number then. Then let's take in the first. We had, I just want to justify this, guys. We had 0,1 recurring. Now, without making any calculations, let us get to the answer. Denominator is 10 to the power. This is only one recurring number. Therefore, it's 10 to the power 1, which is 10, then minus 1. That will give us 9. And then, what about the numerator? The numerator gives us the recurring number. No, the recurring number plus the digit plus the whole number. The whole number, and the whole number will always be on the right hand side of the comma, decimal comma. So in this case, we are going to take this will be 0 plus 1. Yes, that will be 0 plus 1. The recurring number is 1. It's 1. Then plus the whole is that. Now that gives you 1 over 9. And that is what we got. Now in the second, I just want us to use this, which is recurring plus whole number, then over 10 to the power n, then subtract 1. That's it. Oh, my formula. Hey, even Einstein, I think, did this. Okay, let me go to the next one. Now, let us do this one of 2,1 recurring. Now, for 2,1 recurring, we take the R recurring number. The recurring number is 1, then plus the whole number, then over the number of recurring is only 1. That will be what's that? That will be 9. And then what do we get? What do we get? I just want to check this. We have to check it, guys. No, you don't. A whole number, which is this. It can be this. No. Where did we get this? It's 1 plus 2. It's 1 plus 2. Now, what is 2? 2 is 9 over plus 9 over. It's 9 over 9 times 2. 9 over 9. 2 times 9 over 9. Ne? 2 times that will be 18 over 9. This is 2. And then What does it give us? This is 19. This is 19. I'm sorry for that. Then over 9. Yes, guys. That's it. Now, you just take that over that. And then that's it. So, guys, this is how we do it. Now, in short, I will say to you, if you want to get this stuff right, you want to get them right, you just have to make it like this. Say, for an example, you have number one, let's say you have 0.7 recurring. You have 0.7 recurring, then you just want to write the answers only. How many times is this recurring? Okay, we have only one number recurring, so that is 10 minus 1 for the denominator. 10 minus 1, that is 9. And then you put that plus 0. That digit, this one, the recurring digit, plus 9 over, 0 over 9, which is 0. Then you are going to get 7. You are done. You are done. And then for the second, this is for a single digit that recurs. Now let's get to this one. Say you have 0.7777 recurring. What do you do? For this, you add 0. Okay. If it's 2 digit, then that will be 99. 2 nines. And then what do you do? This is the recurring number, then you put that. You put it just above that. That will be 77. And that's it. If you have 0 here, guys, no problem. Just put the recurring number over 10 minus 10 to the power n minus that, minus 1. This is 1 digit recurring, therefore it's 10 to the power 1, which is 10, then minus 1. Here we have 2 digits, it's 10 to the power 2, which is 100, minus 1, 99. And that's it. That's it, guys. So what I want you to do now is to go to your books, the ebooks in your website, guys, in the school, Genius Tuition Institute, GTI. Yes, that's it. Go there and then go to PDF. Go to PDF book, your PDF book, and then check the questions there. There are questions based on that. And then you do the first 10 on your own, and I need them. You send them via their website, guys. Because we are online, so everything is online. We don't need hardwares, softwares. Sorry for that. Thank you guys for having me as your tutor and having trust on me. So guys, maths. When you walk, it's maths. 1, 2, 3 steps. When you count, it's maths. And even when you want to read the Bible, you have to use mathematics because that is a 3D coordinates. In order to get the verse where you want to read, that will be the name of the book, which is another axis, then the chapter and a verse, both 3D. So without mathematics, we get nowhere. So let's do it, guys. Do it. I am here with you guys. Remember, I stay in South Africa, Free State Province, but originally from Limpopo. But I am staying now in Free State. Lady Brand, thank you, guys. Thank you for having listening to Dups the Genius, and we are going to take the genius out of you guys. Let's do it. Thank you, thank you. You are already geniuses. Thank you, guys.